So for number 11, we're going to be proving theorem 1.32a. So this one here, and then we're going to be showing that its converse is false. So for this theorem is a conditional statement of the form if P then Q. Now remember that a conditional statement is always true in all cases except when P is true and Q is false. So we can begin by assuming so we'll begin assume that this is true, right? We're going to assume that this is true. Because if this is false, then the conditional is true because the antecedent is false. So we only care about where P is true because that's the only case that could give us trouble. So we have to show that P is true and then show that Q must be true, right? So we're going to begin by assuming that this is true. And if this is true, we're going to say then the truth set of the unique existential has exactly one element by definition. And then we say, okay, if it has exactly one element, then the truth set is non-empty. Non-empty, right? And so if the truth set is non-empty, thus by definition, we can say that there exists an X such that AX. And we're done with our proof. So we've just began by assuming that P is true. So we said, hey, assume that the unique existential is true for A of X. Then this must mean that the truth set has only one element. And so if the truth set has only one element, it's non-empty. And so if it's non-empty, then we can say that the existential statement is true. And then for B, we want to show that the converse is false, right? We want to show that the converse, so let's change this around. So the converse is the existential. So this is our A, and let's do our B. So the converse is the existential of A of X. If it exists, then it implies that the element exists uniquely, right? So let's do this one. So once more, we'll begin by assuming that P is true. So we're going to say assume, right? And actually, for this one, we can just give A of X a form, right? Assume that there exists an X such that A of X where A of X is equal to, and we'll just give it a form, right? Where X is greater than 0 in the set of integers. So basically, to show that this is false, we have to show that P is true, but Q is false, right? So if we're assuming that there exists an X such that A of X is true, then the truth set is let's see, is 1, 2, 3, 4, and so on. But maybe we can say instead, but then the truth set is the truth set has more than one element. Thus it is not the case that we have a unique element x such that a of x. We've shown that it is false. So basically, we show that p is true, and if p is true, we came up with scenario for a of x where q was false, right? We said a of x is greater than 0 in the integers, and then we shown that the truth set contains several elements. So the truth set has more than one element, and thus the unique existential statement is false. And that is it. We'll limit our item 11 to be just these two.